Lynn.
And so we're going to solve some trig equations, and this is over the interval 0 to 2 pi with no calculator. So when I look at this scenario, this is just simply a quadratic. It's the same thing as 2, something like 2, like a squared minus 7a plus 3 equals 0. It's the same kind of scenario as that, except instead of a, we have a cosine.
So we know with quadratics, one thing to do is we can factor them.
Yes.
So this one factors quite nicely. We have 2 cosine x.
Over here's a cosine x.
And minus 3 minus 1.
Minus 1. That works out lovely. And so then I can say 2 cosine x minus 1 is 0.
Or cosine x minus 3 equals 0.
I solve for cosine, which is add the 1, divide by 2, and cosine x equals 3. Well, this is one of our special ones. Our reference angle is going to be pi by 3, and it's positive, so x will be pi by 3. And I also need to, here's cosine's positive here and here from Sex and the City. So I need to go down to here, which is 5 pi by 3. Cosine x equals 3. My unit circle, no value of x is ever, of cosine x is ever bigger than 3. So this does not have anything, no angle, no solution. That's what I should write, no solution here. And so I get pi by 3, 5 pi by 3. Good enough. Let's try another example. This one's a little bit different. Here we have 2 sine x minus pi by 4 plus root 3 equal to 0. Well, when I look at my interval here, my interval is talking about x. My angle, though, is x minus pi by 4. So one of the things that I've picked up over the years is I'm going to change my interval to reflect this. I want it to be x minus pi by 4 at first.
All right, so if you're going to minus that on the inside, you have to do it also to the left side. So we have negative pi over 4. And to the right side, which gives us 3 pi over 4.
Okay, so now we're going to solve for sine. I get 2 sine x minus pi over 4. Subtract the root 3.
Divide by 2.
Okay, and I get sine minus pi over 4 equals negative root 3 over 2. Well, remember, this whole thing is my angle. So when I find my angles, x minus pi over 4, I think about my sine is negative in
the third or the fourth.
But I'm only looking at negative pi by 4, which is somewhere about here, all the way to 3 pi by 4 over here.
So we can just ignore that third quadrant.
Right,
there.
Totally. And so I'm only looking for, my reference angle is going to be pi by 3 when sine is root 3 over 2. So it's a pi by 3. And the only one that satisfies it being negative is the one in the fourth quadrant. So it's negative pi by 3. I have to solve for x though.
Yep, so you have to get rid of that negative pi over 4 by just adding it. Now we have the final answer where angle x would be
negative pi over 3 plus pi over 4. Now my fractions.
Common denominator.
All right, it's going to be 12. And this will be negative 4 pi over 12 plus 3 pi over 12.
Yeah.
Did I do that right?
Yep.
And so I get negative pi over 12. So x equals negative pi over 12. So when I look at that, just to summarize, I change my interval to reflect the angle I'm given. But still my very final answer is within the given interval that I had. I changed it to fit the angle at first, and then I adapted everything at the end, subtracted pi by 4, and so my correct answer is where it's supposed to be.
Yeah, it's always good to go back and check that.
Okay, great.